When dealing with a data set of this size, it's useful to organize it into chemical families. In ADMET Predictor, you can activate a separate classes tab that gives you a lot of flexibility in performing that organization. The simplest is to use one of the built-in algorithms. The default one, called Frameworks, is based on the well-known approach described in the paper by Bemis and Merco, where scaffolds are comprised of ring systems and linkers. Again, it's very fast to run on this 25,000 compound set. Roughly 1,000 classes were identified. Each is represented by one row in this tab. If I double click here, you see that the common scaffold for the class is shown in blue. You see the number of compounds in each class. You can optionally add property histograms. This is predicted log D and permeability. And you see that the classes are automatically organized so that classes with similar scaffolds are placed next to one another in the spreadsheet. You can perform substructure searches here in the classes tab. So if I repeat that steroid query, you see that the software identified a number of closely related steroid scaffolds all grouped together. If you wanted to combine these into a single steroid superclass, you have the flexibility to do that. So now there's a single steroid class with 702 members. If you want to add classes using scaffolds that you have drawn yourself, there's an option to do that as well. So here I'll launch our sketch tool. This is MetChem Designer. I'll clear that and load some previously drawn scaffolds, some Marcouche and some exact. I can just transfer those back to Predictor, perform that search, and then the software will add a new class for each of the scaffolds that was actually present in the data set. So you see you have a lot of flexibility to organize the compounds however you like.